Okay, in this video lecture, I am going to cover the second part of section 7.1, chemical names and formulas. So the first part, we spent a lot of time naming ionic compounds. We're figuring out ionic formulas based on their names, figuring out charges. Do the charges balance? How many do I need to balance out those charges? And some of you, you struggled at first, and then, now you feel pretty confident, or maybe some of you are still struggling with that. And that's typical. I usually get that every year. But for those that are struggling, I think you are going to like this section. Okay? This second part, naming molecular compounds, covalent compounds, is so much easier than ionic compounds, I think. So this is where I'm going to throw in prefixes and then figure out the formula based on its name. There are different rules for these molecular compounds. And so, your assignment today will be on molecular compounds, but then we're going to mix it up. You're going to get them where you're mixing, and it's not going to say these are ionic or these are covalent. You have to be able to recognize an ionic compound versus a covalent compound. So naming compounds, again, it's a two-name system. We have a binary molecular compound, and there's actually two systems. The new stock system, which we will cover on section 7.2 at the next lecture. And then we also have the old system of prefixes, which is this lecture right here. And so the rules for naming compounds is the name of the first element as is. If there's more than one, then you need a prefix. The second element is named as if it's an anion, which means we change the ending to IDE, and the prefix is always needed in the front. So I'll go through the prefixes on the next slide. The O and the A at the end of a prefix is usually dropped when the word following the prefix begins with another vowel. So I'll take a look at this diagram here. I have N2O3. So it's nitrogen, but there's more than one, and I have to use the prefix. So here's my prefixes. If there's one, it's mono. If it's two, it's di. If it's three, it's tri. 4 is tetra. 5 is penta. 6 is hexa. 7 is hepta. 8 is octa. 9 is nano, nana. And then 10 is deca. So if there's more than one, then you're going to use a prefix. If there was just one, then there's no prefix on this first name. But there's more than one here. So the prefix for 2 is di. So I'm going to say dinitrogen. And then I look, it's O3. So what's the prefix for 3? It's tri. And then oxygen, but then we change the ending from gen to IDE. So trioxide. Dinitrogen, trioxide. Okay, looks like I got a link here. And I'm not sure if it's going to play because I might need flash. All right, that's a bust. Unless I'm missing something. Okay, moving on. So simple covalent compounds composed of nonmetals. That's one way that you can tell it's a covalent. Nitrogen and oxygen are both nonmetals. They're named like ionic compounds, except now we have prefixes. So IF5, iodine pentafluoride. Iodine, there's just one, so there's no prefix on the first name unless there's more than one. And then there's 5 fluorines, so penta, fluor, and you change the end into IDE, fluoride. N2O5, dinitrogen pentoxide. So it was penta, but we're going to drop the A because oxygen starts with a vowel, so pentoxide. Look at CO. Okay, we have a carbon and an oxygen. You don't start names with prefixes in covalent compounds unless there's more than one. Okay, but here we just have one. It's not monocarbon monoxide. It's just carbon, and then there's only one, monoxide. And again, we drop the double O there. This is an ionic compound. It's a metal with a nonmetal. There's no prefixes in ionic compounds. This is just magnesium chloride, That's from the first part of 7.1. All right, got another link here. Oh, looks like it's just another bust. Okay. So we're going to go through and name these compounds here. N2O. There's 2 nitrogens, so di-nitrogen, and there's 1 oxygen, monoxide. NO. We don't say mononitrogen, we just say nitrogen, and there's 1 oxygen, monoxide. NO2. So we have nitrogen, and then 2 oxygens, dioxide. N2O3. Well, there's more than 1, so we're going to have to use a prefix here. The prefix for 2 is di, di-nitrogen, and then there's 3 oxygens, trioxide. N2O4, well, more than once, we'll use a prefix, di-nitrogen, and the prefix for 4 is tetra, so we'll say tetroxide. N2O5, 2 N's, di-nitrogen, pentoxide. SF6, sulfur, no prefix because it's just 1, hexafluoride. CO2, carbon dioxide. P4O10. Okay. Tetraphosphorus decoxide. Oh, decaoxide. Well, they kept the double vowel on that one. P2S5, diphosphorus pentasulfide. Okay. So I think we have some examples here. Okay, so P is phosphorus, and then 5 chlorines, prefix for 5, pentachloride. Change the end into IDE. All right, this one. We've done this one, but we'll do it again. NO2. There's just 1 nitrogen, so nitrogen, 2 oxygens, dioxide. All right, BF3. B is boron. It's just 1, so I'm just going to say boron. Trifluoride. N2O5. I think we saw this one, but there's 2 nitrogens, so we need a prefix. Nitrogen pentoxide. CL4. Okay, this is chlorine. So carbon tetrachloride. IF5. Iodine pentafluoride. NO. Oh, there's just 1 nitrogen, so nitrogen, there's 1 oxygen, monoxide. Okay, over here, we have to give the formula. Let's see if we can go backwards. Silicon, what's the symbol for silicon? Look on the periodic table, it's Si. Si. And then tetrabromide. So what's bromide? Bromide is bromine, that's Br. And how many bromines do I have? Tetra, which means 4. Okay, xenon tetrafluoride. Xenon, I just have 1. Symbol of that is Xe. It's a noble gas. Tetrafluoride. Fluoride is fluorine. Tetra means 4 of them. Oxygen gas. All right, I'm so glad I have this as the example. So oxygen gas, oxygen by itself is reactive. So oxygen gas is actually O2. Okay, O2. If I gave you nitrogen gas, what would that be? That would also you'd also have two of them, right? So they're just paired or bonded to each other. How about hydrogen gas? It'd be H2. Okay. How about chlorine gas? Cl2. All right, so if you ever see that, it just means there's two of them. Okay, switching gears. Acids and salts. So acids are a certain type of molecular compounds, and there's actually two types, binary acids, which means there's two elements, usually a hydrogen, like an H, right? Hydrogen H, and a halogen, like chlorine. So HCl, hydrochloric acid. Oxyl acids, this prefix oxy means it has hydrogen, but oxygen's the big one there. And then a third element, usually a nonmetal. Okay. We also have to be aware of polyatomic ions that are produced because you either lose a hydrogen ion or from an oxy acid. So here, if you take a look at sulfuric acid, here's my hydrogen, and then we have a polyatomic ion with it. Well, if it reacts and we lose the hydrogen, sulfuric acid becomes sulfate. Nitric acid, HNO3. Well, if it goes through a reaction where H is lost somewhere, then it becomes nitrate. Phosphoric acid, H3PO4. Well, we lose the hydrogen off of that, and it's just phosphate. So we'll see if this is a bust. Yeah, it kind of looks like it. Bummer. Okay, salts are ionic compounds. They are made of a cation and an anion. So just, be aware of those types of molecules. Table salt, a metal and a non-metal, contains an anion from HCl. If you mix hydrochloric acid with another base, like sodium hydroxide, then you can make table salt. Calcium sulfate contains anions from sulfuric acid. Bicarbonate comes from carbonic acid. Let's see if this is a bust. Oh my gosh, it is. I miss Flash. Okay. So that does it. Your assignment, we're just going to focus on the covalent naming. Kind of looks like this. Let me drag the window over here. Okay, so it's this side. You're given the formula and you have to name it. So one carbon, so you just say carbon, and then there's one oxygen. Use the prefix monoxide. Let's jump down to this one. Okay, so I got C3N4, 3 carbons. The prefix for 3 is tri. Tricarbon, and then 4 is tetranitride. And change that end into IDE. So that's that side. Over here, you're given the name, and you just have to write the chemical formula. So carbon tetrafluoride, okay, so I got carbon, so you'd write C. And then fluoride is fluorine, so you write a capital F. And tetra means 4. So CF4. Let's take a look at, I don't know, I was trying to find one. Oh, diphosphorus pentasulfide. Diphosphorus, 2 phosphorus, so P2, and then pentasulfide, sulfide sulfur, S5, so P2S5. So that's the assignment. I'm sure you'll have no problems naming that, and you'll say, wow, that was a lot easier than ionic compounds.